In this video, I will discuss how to construct a confidence interval about the mean. So there are different confidence intervals we can construct. We're going to do the population mean when the standard deviation is unknown. Later on, we'll talk about the population proportion. But for right now, we're going to do what standard deviation is unknown. And the reason why I don't concentrate on the standard deviation being known is because do you ever really truly know what the population standard deviation is? Probably not. In virtually all real-world business situations, the standard deviation of the population is not known. If there is a situation where the standard deviation is known, then that means the mean is also known. Because in order for you to calculate the standard deviation, you need to know the mean. If you truly know what the mean is, there will be no need to gather a sample to do an estimate. So the general formula for all confidence intervals is the point estimate plus or minus the critical value times the standard error. And if you watched my other video, um, this would be the margin of error, okay? Or you also call it ME. Because as we said, the point estimate can be X bar, and then we add and subtract the margin of error. Okay, so this is the actual formula. The point estimate plus or minus the critical value times the standard deviation. The point estimate is the sample statistic estimating the population parameter of interest. The critical value is a table value based on the sampling distribution of the point estimate and the desired confidence level. And the standard error is the standard deviation of the point estimate. So I'm going to show you how to find the critical value and the standard error if you want to do this by hand. So if a population standard deviation is unknown, we can substitute the sample standard deviation, which is denoted by the letter S. This introduces extra uncertainty since the sample standard deviation is variable from sample to sample. We then introduce a new type of distribution, which is called the t-distribution. We will not use a normal distribution here. So the assumptions that we have to make is that the population standard deviation is unknown and the population is normally distributed. We'll use the student's t-distribution to construct our confidence interval estimate. And this is our confidence interval estimate here. It's X bar plus or minus a t-critical value times the sample standard deviation divided by the square root of the sample size. So this t here is the critical value of the t-distribution with n minus 1 degrees of freedom, and it's an area of alpha divided by 2 in each tail. So let's talk about the student's t-distribution. That is where we get the t-value from. The t is a family of distributions, and the critical value depends on degrees of freedom. The degrees of freedom is calculated as your sample size minus 1. And that's the number of observations that are free to vary after sample mean has been calculated. So if you look at this description here, this graph, the t-distribution almost looks like a normal distribution. It's bell-shaped and symmetric, but it has fatter tails than the normal distribution. The normal distribution is right here in the middle. It's the green one. And then I have two t-distributions, and as you can see, the tails are a little fatter. The blue graph has the degrees of freedom of 5, and the burgundy graph has the degrees of freedom of 13. As n increases, the t goes into a z distribution. Okay, that's when n gets larger. So you actually have a student's t table in your textbook, and I'm going to show you how to read it. I just took a snippet here, but I'll show you the graph in your ebook. So let's say we have a sample size of n is equal to 3. That means our degrees of freedom will be n minus 1, which is 2. And let's say we're forming a 90% confidence interval. Since this is a 90% confidence interval, that means that alpha is equal to 0.1. So if you look at this, and I'll make another graph here. I'm not good at drawing. So, and here is 0.90. And then these tails out here will add up to 0.1. So we have to figure out what these would be. So you're going to take alpha, which is 0.1, and divide it by 2, which would give me 0.1 divided by 2, which is 0.05. All right, so we need to figure out uh, the critical value or the t-value that corresponds to that 0.05. So in the body of this table, it does not give us probabilities like it did with the z-distribution. Instead, the body of this table gives me t-values. So this table only looks at the upper tail area. So if you look at this picture here, this upper tail here is 0.5, which is what we will have here, and this is also 0.05. So we have to figure out the t-value that corresponds to that. Well, we know that our degrees of freedom, which will be on the table, we want the one for 2, because that's our degrees of freedom, and we want an upper tail area of 0.05. So we go here. So where these meet up in the body of the graph will be your critical t-value, and that's 2.92. So to find this in your textbook, this is your ebook. If you go to your ebook and you scroll down, you'll see a appendix E, and it says table. And you want to go to table E3. It's the critical values of t. And like I said, it gives you the upper tail area, and that's shown here. Oops, I guess I can't write on this. I'm sorry. All right, so our degrees of freedom will go down here, and then you want the upper tail area, which is in this dark purple. So let's go back to our slide. We're going to do an example. It says a random sample of size 100 of travel times has a mean and standard deviation of x bar equal to 110.27 and a sample standard deviation of 28.95. We want to construct a 95% confidence interval from mu. So I'm going to show you how to do this by hand, and I'm also going to show you how to do it by StatCrunch as well as Excel. So let's write out the information that's given to us. They told us this is x bar. That's our sample mean. They told us our standard deviation is 98.95. They took a sample size of 100. We're doing a 95% confidence interval. That means my alpha is 0.05. So we can figure out our degrees of freedom. Remember, degrees of freedom is n minus 1. So in this case, it's 100 minus 1, or 99. Now we have to figure out what is the t critical value. So if I draw my graph, this in here will be 0.95. That means we have 0.05 out in the tails. So we're going to take an alpha. An alpha will be 0.05. I already have it here. And we're going to divide it by 2. When we divide it by 2, I get 0.025. So basically, I need to figure out the critical value that correlates to this upper area here of 0.025. I need to figure out what that t-value is. So I am going to go to my table, and I want a degrees of freedom of 99. So this part here goes all the way down to 50. So it should have two graphs, because it continues on the next page. So here we go. We got a degrees of freedom here, and we want to go to 99. So 99 is here. I don't know if you guys can see my mouse. It's 99. And then we want an upper tail of 0.025, because we took 0.05 and divided it by 2. So my upper tail and my lower tail will be 0.025. So if I scroll down, I'm in this 1, 2, 3, 4, fourth column where it says 0.025. I'm going to go all the way down to 99. And when I get to 99, I highlighted it, I'll do it again. Or maybe I won't. Okay. It's 1.9842. I just had it. Why won't it? There we go. There we go. 1.9842. So that will be my T critical value that I would use in my equation, in my formula. So let's go back to our slide. So I'm going to plug everything back in. I know my X bar. I now know my critical value of T is 1.9842. My standard deviation is 28.95, and we're going to divide it by 100. So you're going to calculate this out twice. This part here, remember, is the margin of error. And I talked about this before in another video. This is your margin of error. So you're going to calculate, you're going to subtract it first, and then you're going to take it and add it. So that will give you your confidence interval. So it's 104.53 and 116.01. And so what does this mean? That means we are 95% confident that the uh, true travel times is in between. The true average times will be between 104.53 and 116.01. And I'm guessing this is in minutes. Okay, so that's what a confidence interval is calculated with this formula. Now, if you wanted to do this in StatCrunch, let me show you StatCrunch. We're going to go to Stat, T-Stats, one sample with summary. And we're going to put in our sample mean of 110.27, our sample standard deviation, which is 28.95, and we had a sample size of 100. If you click on here where it says confidence interval from you, you can put in your confidence level. By default, this is 0.95, but you can have other confident levels. You can have 0.9, you can have 0.99, whatever. So whatever it says in the problem, that's what you put here. And then we hit compute, and we get our lower limit, and we get our upper limit. And that's the same thing that we did when we calculated by hand. So I really don't expect you to calculate confidence intervals by hand unless you want to. Some students learn better when they understand the concepts better when they do it by hand, but that's up to you. So you can use StatCrunch, or you can use my template. And basically with my template, you put in three things. Once again, you're going to put in the sample mean. You're going to put in the standard deviation. You're going to put in the sample size, and you also need to know the confidence level. Your confidence level is going to be written as a decimal. So since we're doing 95%, this will be 0.95. And my template is kind of cool because I show what the T value is that you would have gotten from the table. And when we did it with the table, we got the 1.9842. And I also show you the margin of error. The margin of error is what you subtract off from the sample standard deviation. The sample mean. Okay, so this is the one that you add and subtract from. And then your lower limit and your upper limit will populate. So we get the same answer, 104.53 and 116.01. Okay, that's the end of this lecture.